Welcome to the demonstration of secured power transmission with overload and over voltage protection. So here we are going to set and change the overload purpose current, and over voltage purpose we are using these potentiometers. Two potentiometers for current and voltage purpose, as well as we are monitoring continuously the temperature. These three parameters continuously monitored on the 16:2 LCD screen, as well as same data will be sent through the RF communication for secure wireless communication purpose, and the RF received data will be sent to the laptop screen through this USB to TTL converter, as it will provide us the TTL data and our laptop can't understand the TTL data. For that purpose we need to convert the TTL data to USB using this PL2303 USB to TTL, TTL to USB conversion. So here we have interfaced these three sensing units to the A0, A1, A2 pins of our microcontroller, and the data continuously monitoring on the 16:2 LCD screen, and we have interfaced that at pin number B2 to B7, and for the wireless communication purpose we interface this RF Zigbee module at B0, B1 of our PIC16F73 microcontroller. So the whole system getting power supply from this adapter at this transmitter unit, and this adapter will take 230 volts AC input and provide us the 5 volts DC output. Once we provide that 5 volts DC, it start reading input from the input sensing modules and controlling the output modules along with data transmission. So on this motherboard, so this one is the reset switch to restart the microcontroller, and this steel plated one is a crystal oscillator which is used to provide the clock pulse to the microcontroller. So the purpose of crystal oscillator is we have provided the set of instructions to the microcontroller that is reading input and controlling the output and sending data to the wireless communication. So these instructions need to be executed based on the clock pulse for the microcontroller. Each pulse will execute each instruction. So let us see the demonstration. So before demonstration, first of all we need to set up the laptop with applications. So this is the previously tested output. So like this we got the voltage in V, current in milliamps, and temperature in degrees centigrade. So this is the application of hyper terminal. Through that we can monitor the data. So before this demonstration in your laptop, the first setup is we need to install PL2303. You can disconnect this. Right, so don't keep anything into that, and install PL2303. Yes, and if it is asked for .NET application update, install that, and after that reinstall this again. So end of this, it will ask you to insert the USB to TTL. Insert that any one of the USB slots. After insertion, continue, and no. Here this is a very important step. Don't restart the PC or laptop. Finish. After that, go to this PC. Right click on that. Go to show more options. Then in that go to manage. Follow the steps clearly one by one. After manage, device manager. After that, here we can see the ports. Okay, and when we enlarge that, there we can see the COM7. If it is showing like please contact your service provider or dealer, instead of showing the COM number. So here we got the COM number. Instead of showing that COM number, if it is showing any error, then right click on that, update driver, browse my computer, then let me pick from the listed one. Then here we need to select the 2008. We need to downgrade that. Okay, and close. When we close that, there we can see the COM number here, COM7. If it shows error, otherwise next step is you can close this and go to our folder, new folder, in that hyper terminal, because we have already installed this and we got the COM number. Remember the COM number, and in this click on this icon. Okay, it will ask for the name. You can enter any name, any name. Next, connect using the COM. So COM7, as we got that from the device manager. Okay. And next restore defaults. Right. And okay. So any name, COM number, restore defaults, then okay. Right. Now the system got connected to the USB to TTL. Now we can on the power supply to this. So on the power supply to the kit. So welcome to the project initially, and continuously the data streaming which is up like displaying on the LCD screen. Same data we can see on that. So let us make a high voltage, just increasing that voltage. There we can get the alert message on this alert high voltage, and when it is normal again we set the limit of 240 volts, and current also 100 milliamps. When it is above 100 milliamps, right, so there you get the high current alert message in your laptop screen. Temperature we set the limitation is 40 degrees centigrade. Right. In this manner securely we are transmitting the data to the laptop at the monitoring section using the Zigbee RF communication module.